So beginning our lives, we have domain and range, just remembering what that looks like. So here's a domain and range example using the quadratic equation. So as you can see here, we have our function. We're talking about where it's filled, where it's not filled. And the domain of this function, taking into consideration x and y, consists of the shaded region. So all of that's there, visible, but ultimately we're bounded by y equals x squared. And then from there, we're going to take apart and break this down. But this is a visual. If you have a cup and you're filling it up, what are you talking about? The interior. What's happening on the interior? Well, the interior is y minus x squared is greater than 0. So that's why inequalities were important the previous day. And we're just going to start word problems. So a car's speed is 20 miles per hour, and it accelerates at 5 miles per hour each second for 6 seconds. For 6 seconds, write a linear function that models this situation. Choose both an appropriate name and appropriate variable for the function. State the input variable and what the input variable represents and the domain of the function. All right, so the first thing you want to do with most problems is make a table of the information that you have. So if I look here, it tells me that the car's speed is 20 miles per hour and it accelerates at 5 miles per hour each second for 6 seconds. Write a linear function. So this example is what we call a model of a piecewise. So it's more like a step function when you think about it. I'm on the wrong thing. So tabulating it. And my pen's not working, y'all. Oh my gosh. Oh, there we go. Oh, today was going so well, and then all of a sudden. So we have our slope equals 20 miles per hour. And we're looking at our table. We are so this is our time. This is our speed. So at time 0, obviously, I'm doing what? I'm just at 0 miles per hour, right? So 0's at 0. And then, oh, I was like, what is that? Dude. And so a car speed, and here we go for 6 seconds. So from 0 to 6, I am going 20. Make sense? And then from 6 to 12, I would be going what? It says I accelerate each 6 seconds. How much? So now I was going 20. Now I'm going 25, right? And then from 12 to 18, I'm going. And then from 18 to 24, I'm going 35. And then we get the pattern. Do we see it? All right. So what I want you to think about is, how can I represent this as a function? What's happening? How? Oh, it doesn't want us to do that, does it? Oh, it just wants to state with the input variable. So my input variable would be the time, and my domain of the function would depend on how far I'm going, right? It doesn't give me a stopping point, but it would depend on where I'm going. So what I do want y'all to talk about with each other is you're going to do this part. Is choose both an appropriate name and an appropriate variable for the function. State what the input variable represents and the domain function represents. So talk out loud, communicate. At home, people, I can open the chat window and you can talk. It'll just be there with the picture. Jesus, take the wheel. All right, so now we're on to this word problem. We have a 400-gallon tank initially full of water. It is being drained at a rate of 20 gallons per minute. Okay, first we're going to write a formula for a linear function that models the number of gallons of water in the tank after X minutes. So obviously, keyword here is initially. Initially tells me that 400 represents which variable? my B. Okay, that's what it represents. Okay, and then 20 gallons per minute, that per lets me know this is my what? My M, my slope. And why is it negative? Is draining, that draining right there. Okay, so when I write my function, it's going to be f of x equals 400 minus the 20 gallons. Do we see that? Are we in all agreement? Did I make any mistakes? Did I make coherent sense? I think I'm back. Okay, so it wants to know how much water is in the tank after 4 minutes. So x equals 4. I'm going to plug it in. F of x equals 400 minus 20 times 4. Do we see how that happened? So we have 400 minus 80, which gives me 320 gallons after 4 minutes. So the difference here between your other problems is that you've been just given straightforward linear equations and you have to evaluate. The difference for this section is you have to create your own linear equations. Okay? You are reading and creating. Let's keep going a little further. It wants us to graph and identify the x and y intercepts. We're not going to graph, we're just going to identify the x and y intercepts, okay? So if I'm identifying the x and y intercepts, remember, there's a couple of ways. You either get, what was our equation? Y equals 400 minus, was it 20? Yeah. Okay, so off the back, we know what our y-intercept is, right? What is your y-intercept? 400. Y-intercept is 400 gallons initially. Okay, your x-intercept is what you're going to find next. So remember, for x-intercept, all you're doing is plugging in 0 for y. So 0 equals 400 minus 20x. And you're going to subtract 400, and that leaves you with negative 20x. And like Zane said, when you divide it all out, you're going to be left with 20. What does your x-intercept represent? There you go. Your x-intercept is after 20 minutes, is it a tank? Yeah. The tank will be empty. So the y-intercept is our initial, and our x represents our emptiness. There you go. So therefore, based on the fact that this is a real world problem, are you going to have a negative amount of time? No. So our domain for this function would be x is greater than 0, but less than or equal to 20. Questions, comments, or concerns? Okay, word problems are stressful because you're creating the information. You're reading and you're building your own equation and then you're analyzing it. But we're all big boys and girls around here and we got this. I only clicked it once, I hope. All right, so the table shows the distance y in miles traveled by a vehicle. So using x gallons of gasoline. So I can go on 5 gallons, I can go 194 miles. On 10 gallons, I can go 392, okay? This is pretty straightforward. The only difference between this and a problem with just a table is that they now have defined what your x and y are. They are telling you what's your independent and your dependent variables. Should it change how I find the slope? No. But what we're going to do is you're going to find the slope of each one. So you're finding the slope from here to here, here to here, here to here. All of them. It says line segments. It doesn't say segment, it says segments. Okay? So remember to calculate your slope. So to find my first slope, how about your calculators? You guys are going to do the math. 392 minus 194 divided by 10 minus 5. 198 over 5, and give me an approximation to the nearest 10. To the nearest 10. Okay. All right, so that's slope 1. I'm going to do slope 2. And our slope 2 is 580 minus 392 over 15 minus 10. What's the exact? 198. Was it 188? I was like, over 5. Give me an approximate to the nearest 10. 37.6. Awesome. And then the last one in 3, that's 781 minus 580 divided by 20 minus 15. Exact? 2 what? 201 over 5. Approximate. 40.2. Okay. How do you feel about finding the slope of the consecutive points to create the multiple segments? Are we good? Okay. Now, because we found the slopes, what we're going to do is we're going to use this to find the what did my page go? We got to find that. We're going to use this to find the average slope, and that'll help us be able to create a graph. So we're going to take these values and find their average. So we're going to look for our average slope. So if you take these values and find their average, what do you get is my average slope? So 39.6 plus 587 over 15. How'd you get that? When it? Oh, no, I thought you said you just added it first. And then what's the decimal? 39.1. 39.1. So that's our average slope. That's what we're going to use to write our linear equation. The reason why we have to find the average is because they're not consistent slopes. Does that make sense? So you have to find the average of what's happening. So on average, this vehicle gets 39.1 gallons per mile. Does that make sense? So here, if I find a linear function that models the data, well, we found it. We found the average of our slope, so therefore f of x equals 39 and 1/10 x. So if I was to graph this, I would be here at 0, and then my graph will be, this is a poor graph. Pretend that these are hundreds. This is 100, 200, 300, 400, 500. That'll work. So at 5 miles, I would be somewhere in the 200s, right below. And then at 10, I would be somewhere in the 300-400s. Why did it erase my dot? Who told you to do that? Seriously? Y'all saw that too, right? Okay. This is the straightest line you've ever seen. Okay, so there's my little sketch. And again, what does the slope represent? Slope represents gallons per mile. So slope equals gallons per mile. And our gallons per mile is 39 and 1/10 gallon per mile. So if I asked you, I thought I asked you. If I have, let's see, find f of 30. What would you do to do that? We have our equation. I've given you function notation. So what are you just doing? You plugging in and multiplying, right? 39 and 110 times 30 is going to put me at what? How far can I travel? 1170. I can go 1,173 miles if I have 30 gallons of gas in my car. Okay. All right. Let's keep going. We're going to talk about piecewise. Piecewise. Okay. Piecewise functions mean that your graph is in pieces, literally. Uh-oh. So if we are to look at this example of a piecewise function, this is what real life is. Because is everything perfectly linear at the same time all the time? No, those are approximations. Reality is you may start off increasing, and then, oh no, I increase even faster. Then, oh no, oh crap, I'm going down. Okay? This is a real life situation. But notice at each transition, only one value is defined. That's why it's a function. Because at each transition, only one value is defined. So looking at my inequalities, see that this one is just less than, this one is less than or equal to. If this is less than or equal to, then this has to be just greater than. You're not defining at every single value for that x. Otherwise, it's not a function. Okay? So are we ready to dive into piecewise? Real life situations. So the table here, it lists percentages of population that did not have a high school diploma for the selected years. So in 1960, 28% of the population did not have high school diplomas. In 1980, 14%. In 2000, 11%. And in 2010, 8% did not have a high school diploma. So when we're looking at this, if we were to plot the graph of this data, it would be, how do I want to plot this? I don't want to plot it, in all honesty. I'm going to just do a sketch. So say this is at 1960. Well, from 1960 to 1980, it's going to be a what? Oh man, that is a pretty straight line. I'm so proud of myself. Maybe these should be real points. This is going to be 1960. This is going to be 1980. Man, look at Shauna. And then I'm still decreasing, but is it as steep of a decrease? No, so it's decreasing, but not as steep. And then in 2010, I'm still decreasing, and it's kind of following the same trend as before. So it is following the same trend as before. So notice here that I have two different slopes taking place. I have a fairly steep slope here. So this is slope 1. And then from here, I have a second slope here and a third slope here. So this graph is going to be represented in pieces, okay? That's how you know that it can be a piecewise. Uh-oh. So each line, I would find the slope between this one. This would be my M1, M2, M3, okay? So we're going to find each one. So M1 equals 1980 minus 1960 over, which way did I write it? I think I wrote it 14 minus 28. So I have 20 over negative 14, which is equal negative 10 over 7. I wrote it upside down, Gina. What are you doing with your life, Shauna? Yes. M1 equals 28 minus 14 over 1960 minus 1980. M2 equals 14 minus 11 over 1980 minus 2000. Does it really matter which one I write first? No, just as long as I'm consistent. And M3 equals 11 minus 8 over 2000 minus 2010. All right, what'd y'all get? -7/10. 20? -3/20. 3 over 10. You're declining. And it doesn't matter if the negative's in the numerator or in the denominator, the whole number is negative. Okay, so as a decimal, this is -7/10. This equals -15 1500ths, right? I did the math in my head. Yeah. And then this equals -3/10. So there's the slope of each one. So we're going to use the slope of each one to create the piecewise. So for our piecewise, y'all are going to have to be my information because I have to switch slides, okay? So you're going to tell me, does everyone got this information down? So that when I ask you, you can tell me? Okay, cool. So when we are, in order to find where this continues, we're going to write the function. So my first slope is what? What was M1? -0.7x, right? And that's from what year to what year? 1960 to 1980. Okay, and then my next slope is negative, and that's from 1980 to 2000. And then my last one is 2. So I have my equation. At every point between this on my domain is everything defined. 1960 to 1980, yes. 1980 to 2000, yes. 2000 to 2010, yes. So it is a continuous domain. And that's because on my domain, every point between these can be defined. And from your domain and looking at your equation, just from the slopes, you should be able to tell me where it's increasing and where it's decreasing and where it's constant, right? So I know that on all of them, they're going to be what? Decreasing because the slope is negative. So negative slope equals decreasing. And positive slope would be increasing. And if you didn't have a constant, so just a constant number, obviously means that it is constant. Just want to state for clarity that it's just a number, which is a constant. It is a constant situation. Just reading from, as if you read it from left to right. Sometimes they'll tell you at specific points, but it's for the most part. If I plug 1980 from here, because it was 1960 minus 1980, is typically how it'll happen. But yeah, you just read it from left to right. just like you would read a book, the best way for your piecewise is to go left to right. And the beginning, also that can be equal to, because it's not defined at any given point. It doesn't have to worry about that. All right. What are your questions about finding, identifying if it's a piecewise? So plotting the point, seeing the change in slope. Questions about that? What are your questions about finding multiple slopes? We're all good with finding multiple slopes? Don't be Miss Jones. Remember, it's your y. Your change in y over your change in x. Delta y over delta x. Identifying where it's continuous at. So setting up your piecewise and their intervals and making sure it's continuous. How do we feel? Okay. And then knowing when something is increasing, decreasing, or constant when it comes to linear. Negative slope, decreasing. Positive slope, increasing. Constant equals constant. Is it okay if I didn't draw the picture? Or y'all like, oh no, I need my picture. Yes. Discontinuous? No, just non-continuous, I think. All right, and we already wrote our piecewise on the other one. I don't want to rewrite it, but it's there. Oh, we gotta write the full one. So we just did it to identify the slope. That's what we didn't do. So now we gotta write the full piecewise, which is now stating that we need a, what's missing from our equation. In linear, you have y equals mx plus b. Right now, we only have the m, right? So what are we missing? Our b. So for each one of those lines, we have to find their b. Because are they going through 0? No. Graphically, if you look at them, these lines are not going through 0. So they each have their own b. So we're going to find the b of each line and write our full and final piecewise. Now, we're going to do it in the shortcut way. Honestly, guys, you're going to want y equals m times x minus x1 plus y1. That's the format we're writing it in. So you're just choosing an x1 and a y1, and you already have the slope. You do not have to actually solve and evaluate to find the b. Does that make sense? So from here to here, our slope was negative 7/10, right? From here to here, it was negative 15/100. And here to here, it was negative 3/10. Okay? So you can choose either one of these points to create this final equation. I repeat again, you can simplify it if you want, but you do not have to simplify it for me. You can just write it. So when I write my final function, so f of x equals, first one. So the first one, the slope is negative 7/10, parentheses, x minus, and it doesn't matter which one of these points I use. I'm just going to use the first one. And that's 1960. Oh, come on. Plus 28. And the interval from this is 1960 to 1980. Boom. That's that full on. Next, we have negative slope, x minus 1980 plus 14, and that's from 1980 to 2000. And then my last one, negative 3/10, x minus 2000 plus 11, and that's from 2000 to 2010. And this piecewise pertains exactly to this given information. And if you want to, you can distribute a value If distribute and combine like terms, whatever makes you happy. But if you get to this, I am fine. Do we understand where this came from? That this is just point slope? Agreed? Okay. That's just a point slope form. Because you have a point and you have a slope, and if you evaluate, you will have a y-intercept. Questions, comments, concerns? Okay. So just reviewing, making sure we're comfortable. Things that you should be comfortable doing at this point. Excuse me, plotting points. So picking any value of x, substituting it in, and figuring that out. That's one method of graphing linear equations. Using x and y intercepts. How do we do it? Find the x-intercept, find the y-intercept, plot them, join them. Okay? Your other option for plotting points, slope and intercept, your rise over your run. So at this point, you should be able to graph a line by hand. Very fine and comfortable. Agreed? Anyone doesn't feel like they could do this, do it by hand. Okay, what would be your step? Have you even read the steps? So why are you saying you can't do it? Huh? Steps are pretty straightforward. So here are your 3 steps, your 3 options to graphing a linear equation by hand. And all 3 work. So yes, they're options. All right. So this is coming to point because graphing. So here's our piecewise. So evaluating a piecewise. First, being able to state the domain of the piecewise. When you look at this piecewise function and you're going to state the domain of it, first thing you want to know is it continuous? Is everything defined from one piece to the other piece? Yes, so it's continuous. And because it's continuous, I know that my domain is from -3 to +3. That's my domain. No breaks, no gaps, no holes. Fiddle part. We will have to finish 2-4 tomorrow before we start 2-5. It's just more word problems and practice with piecewise. I think it's my fault with all my glitches. I'll take responsibility. Does anyone actually watch the videos?